Ever wanted to get up close and personal with the stars? Maybe even a planet or two? How about a galaxy? Hey, maybe even a quasar? Don't worry, I don't know what that is either, but we'll find out soon enough. Albert Einstein was actually in this room.
Yes. We're standing. Are we ready?
No. We should probably stand underneath there. Join me today as I tour the Yerkes Observatory. And tour the beautiful 77-acre site. I hope to learn a thing or two along the way, although I probably won't remember it all.
Saturn is in front of the telescope. We could observe Saturn at 8:40.
Watch me as I take a ride on the mega telescope. The Yerkes Observatory is situated in southeast Wisconsin on Geneva Lake in Williams Bay. I'm excited about my trip today. I've heard the tours are very popular and entertaining.
So you leave the telescope like that and move it this way.
Established in 1897 by Professor George Ellery Hale, this facility is part of the Department of Astronomy and Astrophysics at the University of Chicago. Hale's fascination with astronomy started when he was a young boy. He was absolutely enthralled with the sun and discovering its structure. He made it his mission to uncover the mysteries of the bright star. When starting with the university, Hale immediately worked on gaining access for astronomic research. He obtained it when the observatory first opened its doors. To this day, this large site provides researchers with access to telescopes and lab space not found within the confines of the busy Chicago area. The observatory has an exciting history, and I'll be meeting up with my tour guide to explore the facility. Now, if I could only find my tour guide. There you are. Hi. I'm saving the best for last. Before I go face to face with a mega telescope, I first head outside for a tour of the beautiful outdoor grounds and architecture. Why is the observatory called Yerkes?
It was named after Charles Tyson Yerkes, who paid first for the magnificent 40-inch lenses, then for the telescope completed by Warner and Swasey, and finally for the entire building. So he gets credited with paying nearly $500,000 in 1890s dollars.
What year was it built?
1895 to 1897.
So I noticed there's two huge domes. This is the larger dome that we're standing outside of. And how large is that?
That's the 90-foot diameter dome.
The two smaller domes on the north and east side contain telescopes which are 41 and 24 inches in diameter. Are both of those in use
They
today?
are both in use. The 24-inch dates from 1965, the 41-inch from 1967.
And how did Hale become involved with this?
George Hale was keenly interested in studying the sun because he reasoned quite correctly that the sun is a mere star and that the stars do not show the surface features we can see on the sun. Hale invented ways of photographing them and studying them without setting anything on fire and without damaging your eyes, which are important considerations. So this was, in the 1890s, an observatory for studying the sun during the day and everything else at night.
In the 1890s, the Yerkes 40-inch refractor telescope was considered to be the largest in the world. Coming up next, I learn the interesting history behind the architecture in the entryway. I noticed there's all kinds of different architectural features on the outside.
And all of this is Roman brick with cast terracotta details.
And these are special symbols.
They all may mean something. All of this, it's cast. Man in the moon with a star, again, again, and again, 3 times on each pillar. Henry Ives Cobb, the architect, the University of Chicago architect, hated Gothic. He was forced to do the University of Chicago with all its grotesques. That's really the proper word, grotesques. This was what he really loved, Greco-Roman. Unfortunately, he decided before dying that when he was going to die, when he died, he requested that all his personal papers be burned. And unfortunately, this included notes about the architectural details. People have their personal notes burned.
Yeah, well,
I don't know. Why did my mom ask me to burn her diary after she was gone? Being a dutiful son, I said, yes, I would.
That's history, now that's gone.
That's why I didn't burn it.
Good for you.
Thank you. Well, the problem with that is I can't read her handwriting.
Oh. I'm anxious to find out the significance of what this all means. Plus, the proper way to refer to these lion-looking creatures is revealed.
We don't understand this one. There's a turtle coming out.
Turtle head.
Turtle head. Why a turtle?
Why?
We don't know.
Now, if we would have had those notes, we would have
We might have.
That is not a gargoyle.
No, that is a winged lion, and we have winged lions all over the place. Here, we never talk about them as gargoyles. Gargoyles originally were drain spouts, water spouts, so the water would be coming, for example, outside a monster's mouth. Ours are winged lions, for which there's no term in the English language. Ours are not griffins, because a griffin has an eagle's face and usually an eagle's talons. It's crossed between an eagle and a lion.
I turn into a winged lion when I don't eat.
Yeah.
That's
okay.
me.
Well, I haven't had breakfast. I'll give you a Valvita cookie. They're really good.
Ooh. That would be kind of cool if that was a gargoyle with the water.
It would be. Yes.
Yeah,
we like our winged lion. There's some smaller ones up there. There's a winged lion.
Okay. I really wanted that cookie. But in addition, what I wanted to know was the meaning behind all these symbols. Were they actually secret code for something?
Directly above a shield with tools of the architect, people have looked at that and said, oh yes, a pair of drawing compasses, a T-square and a right triangle. It must be a secret Masonic device.
It must be.
Yes.
But it's
but it
not.
Isn't. Sometimes, as Sigmund Freud might have said, a pair of drawing compasses, a T-square and a right triangle are just a pair of drawing compasses, a T-square and a right triangle.
Plain and simple.
Plain and simple.
Well, there you have it. We'll just have to keep looking for clues to discover the mysteries of these drafting tools. But for now, I certainly can appreciate the beautiful architecture. All 12 signs of the zodiac are represented on the pillars. Let's see. I wonder where my sign is. Where's Capricorn? That's me.
Capricorn the goat.
Wait, here.
No, that's Taurus the bull.
That is Taurus the bull.
This is,
oh, here. Got it.
Yes. Capricorn the goat
There
being
it is.
capricious. Yeah. So we are full of all sorts of designs. Think of them as just beautiful designs.
Alongside this fantastic architecture is the main event, the Yerkes 40-inch telescope. I'm gonna go inside and see if I can take a peek. Maybe I'll make a discovery of my own.
We do not let you do this during the tour.
I can't promise that I'll behave myself either.
We do not let people do this during a tour.
So we're standing where the 40-inch telescope is.
Yes.
And we're about to raise
The 73-foot diameter elevator floor.
So it's an actual elevator.
Yep, been
And
here since 1897.
And what is the reason why we raise it up?
Well, in order to get to the bottom of the telescope, we turn on a motor downstairs. The green weights move down, and I whistle where no man has gone before because it sounds a lot like the Enterprise speeding up.
You're on.
So the floor can go, if necessary, as high as that balcony way above our heads. When I let go, it makes a little scream like that. We can, of course, move the telescope from north to south. I'm about to move it to the north. The telescope moves so that the eyepiece is getting lower and lower. Once we're close enough, I can reach the control paddle and take the elevator floor even higher. I can't do it, not tall enough.
Not
We can
yet.
take the floor higher.
Let's do it.
I'll let you
Okay.
pull off the control.
You need to get way high.
I'll let you move the floor now, although it's more fun to watch you do it.
Got it.
We do not let people do this during a tour. Just push and hold that button. I see. Well, apparently that doesn't work. Oh, all right, never mind. You can, however, move the floor up, push there where it says floor. And this floor, with us on it, is now moving up.
So as long as I have my finger pressed on there,
Right, but
operational.
I'm trusting you will let go before we hit the telescope. This is the eyepiece.
okay.
So you take the telescope as high as you need to get to the bottom.
I think I'm
Yeah.
high enough.
I think you are.
I think so.
I'm now slewing the telescope. Click.
What is this tower right here in the middle?
That is the pier that holds the telescope upright. It's hollow. The floor can go as high as the balconies surrounding us.
Oh, really? This whole thing can lift? Now, of course, you'd want to have the shutters open.
You move the telescope, yeah, and you move the telescope first. But over here, you will be able to see the two shutters that move apart, making an 11-foot wide opening that goes all the way up to Spider-Man.
There's Spider-Man.
There's Spider-Man.
How do you get up there?
I don't know. It's a bit of a mystery.
Just
More importantly, how would we get him down if we don't want him up there?
And what is this dial?
Oh, the dial there with the numbers 10, 20, 30, 40, that's easy. So remember your fourth grade teacher, Mrs. Grundy?
Uh-huh.
She said the sun rises in the east at the equator, and at noon it's directly overhead, and then it sets 6 hours later. Well, this telescope is designed to track things like the sun or stars. That is the agreed upon angle from north to south.
And so this is the actual eyepiece?
The actual eyepiece is right here,
Right here.
about the size of a can of soup.
And so we can't see anything, of course,
Because
because
the shutters are closed.
are closed.
Yeah.
Do you ever open them?
Only when we're doing observations, pretty much for education outreach. The public does not get a chance to look through this telescope. We do offer opportunities for people to look through a 2-foot diameter telescope instead.
And then
Oh,
just lift this?
well, you may come over here. We don't let people do this during the tour, but you're special. Put hands on either side of that. With that, your weight will make it go down and drop you at almost exactly the place, and then you can drop off.
We're gonna-
Are you sure you have enough traction? I can move the floor a little higher.
I'm okay.
Start pushing hard. Oh no, you're pulling.
Oh, pushing.
Would you like me to push it? And
I can.
If you
Oh,
hold,
yeah, there it
if you
goes.
hold on, you'll go up in the air with it.
That way?
You that way. Ready?
Ready?
Okay. Don't let go.
Wait, how am I going to get back down?
Oh, just hang on because your weight will take
Okay.
you back down again. See, the telescope's moving back down again.
It's like a ride.
We do not let you do this during regular scheduled tours. And
Oh,
notice
yeah.
it coming back down. And I'll help you stop it. Aren't laws of
It's
physics
heavy.
wonderful? Perfect. It is very heavy.
Ta-da! After my magical ride on this very expensive piece of equipment, I finally got a chance to take control and move the floor. So we're gonna move the floor down now, and which button do I want to press?
The one that
says floor, huh?
And hold it, don't let go.
Press it down, and
Switch,
as I
don't
do
let
that,
go.
the floor is gonna come down.
The floor is going to go down. And the green weights are going to go up in the towers. If you let go, it'll stop, so don't let go. It will automatically stop. There's nothing you can do to break the floor.
That's a good thing, because I
That is a
often
good
break things. And this is the original floor?
Well, technically it's the second floor, the first one having collapsed in 1897 before dedication. And keep going until it goes, That's perfect. Now,
There
if
you
you're
have it.
looking at the telescope from here, you notice that the eyepiece is a good 20 feet off the ground. So the reason it's that high off the ground is we used to attach various and sundry scientific instruments to it. For example, here's a picture taken of Bill Morgan in 1927.
So, Bill Morgan.
Bill Morgan.
And who was Bill Morgan?
Bill Morgan was an astronomer that came over from Vanderbilt University and got his degree here at Yerkes. This is the year he arrived. And the first thing they did, possibly because he was tall, good looking, and knew how to dress well, didn't wear Hawaiian shirts. First thing he did was stand in for scale while they're taking the 10,000th picture of the sun. 6 years earlier, Albert Einstein won the Nobel Prize in Physics. And here's Albert Einstein in 1921.
So, Albert Einstein was actually in this room.
Yes, he visited. In fact, I could take this photo off and swing it around and hold it to show you where Einstein was standing.
How does that work?
Well, we take this picture and we walk around this way. You can then see the pier of the telescope
Which is right.
and the
there.
telescope up there.
So he was standing right about here.
See that X on the floor? He was standing right there. I'm lying, there really isn't.
There is no X.
But one day we'll do it.
But somewhere here
Yes, somewhere there.
is where Albert
So
Einstein
you
was
should be
standing.
getting pretty much the same view.
And the dome actually rotates?
rotates.
It rotates.
Yeah, and every few minutes we turn the dome.
Let's do it.
Okay. If you were outside, you probably would not hear it moving, but you'd certainly see it moving.
So we're moving it in order to get it aligned.
The telescope can track automatically, and you have to move the dome every few minutes.
As the next tour comes in, I get whisked away to get an in-depth look at the discoveries from the night skies.
So the Hubble Space Telescope was originally put up there because it would not be looking through Earth's blurring atmosphere. If we're looking at the image of a star, when you look at that with a telescope, you see a big fuzzball, like a miniature marshmallow. Adaptive optics is the ability to undo the blurring of the atmosphere. This article was written in before you were born, May and June of 1994, because it started off as a newfangled invention. By 1994, people were starting to use it, and now all big telescopes include adaptive optic arrays.
What exactly is a globular cluster?
Well, they're clumps, globe-shaped, of stars orbiting the center that are found in galaxies of stars. This is a picture of a total eclipse. The day of the eclipse, you can see a ring of fire. This was designed to be on the shuttle in weightless conditions, zero gravity conditions.
What is this?
Well, this is part of the mechanism, including the 4-inch floppy drives, which nobody uses. Look at the keyboard. Why would you have a keyboard that's sideways?
I don't know.
Because you're in weightless conditions, so you grab on something, you can type it.
Gotcha.
This was a top secret Department of Defense instrument.
What was this again?
Those curved rings atop there do important things, so they put a little protective ring around there, so you don't accidentally bump it.
Okay, but we can we bump it now?
Or you could try it. I don't think you should. We'll undo it.
We'll undo it real quick. It's not plugged into anything, is it?
I don't think it is.
Okay.
Those are called Dewar flasks. They're useful for testing things. We just got rid of our really enormous one, which has gone out west and will be attached as part of the mainstay camera to a modified jumbo jet called SOFIA, Stratospheric Observatory for Infrared. It's a former Pan Am jet.
Its job is to survey the atmosphere, performing flights to gather data for tests and scientific observations. The observatory is involved in a joint project with NASA called SOFIA, which stands for Stratospheric Observatory for Infrared Astronomy. The data will then be turned into tangible graphics and images, enabling the visually impaired to experience stars in the Milky Way galaxy. The facility is also involved with mapping the universe. The Sloan Digital Sky Survey involves over 8 years of operations, which includes deep multicolored images covering more than a quarter of the sky and creating three-dimensional maps containing more than 930,000 galaxies and more than 120,000 quasars. A quasar is a dense section in the center of a vast galaxy surrounding its central black hole. This observatory truly is a beautiful pairing of tradition in architecture and the fast-paced world of science and technology. Yerkes Observatory is open for free public tours every Saturday throughout the year, and is a fantastic opportunity to take family time and excite young people about astronomy. It hosts a multitude of programs and tours to inspire a future scientist and maybe even enlighten a spark within you. Until next time, keep on exploring.